In number 2, we're going to compute some derivatives. So in part A, we have a product. Here's the first function, 5x to the 7th, and here's the second one, cube root 10x squared plus 3. So we'll use the product rule. So we have the first, that's 5x to the 7th, times the derivative of the second. So this cube root is exponent 1/3. So we'll bring down the 1/3. And then we'll subtract 1. 1/3 minus 3/3 is minus 2/3. And then we have a little chain rule here, multiplied by the derivative of 10x squared plus 3, so that's 20x. So that's the first times the derivative of the second plus derivative of the first, that's 35x to the 6th times the second. In part B, we have a quotient, so we're going to use the quotient rule. So first we square the denominator. We'll just write it like that. And then put the denominator right up here. Times the derivative of the numerator, that would be 6x. Minus the derivative of the denominator. Okay, this is x squared plus 4 to the 1/3. So we're going to bring down the 1/3 and subtract 1/3 minus 3/3, that's minus 2/3. And then we're going to multiply by the derivative of the inside, that is 2x. Okay, so all that's the derivative of the denominator, and then we multiply by the numerator. In C, we have a product. Here's the first function times the second function. So we'll do the product rule, the first times the derivative of the second. Here we're going to do a chain rule. Bring down the 5. Okay, subtract 1. Times the derivative of the inside. So the derivative of sine 3x is cosine 3x times 3 plus 0. Derivative of 10 is 0. Okay, so that's the first times the derivative of the second plus the derivative of the first. That would be 5x to the 4th times the second. Okay, in part D, we're going to do implicit differentiation. The first term requires the product rule. So let's start. We have the first times the derivative of the second. That would be 2y dy dx. Plus the derivative of x is 1 times the second. Plus the derivative of 5x cubed. That would be 15x squared. Plus the derivative of 2y, that would be 2 dy dx, is equal to derivative of 9, which is 0. And then we just factor out that dy dx. Here we have 2xy plus 2. So we factor it out from this term and this term. Now, these two terms we're going to put on the other side. So that would be equal to minus y squared minus 15x squared. And now just divide by what's multiplying the dy dx. And finally we have dy dx is equal to minus y squared minus 15x squared divided by 2xy plus 2. In part E, this is set up to use the chain rule in this form. We'll write dy dx is equal to dy du times du dx. So if we take this derivative, we'll get dy du, the derivative here with respect to u, and then we'll take the derivative with respect to x here to get du dx. Okay, so let's start. So first we're taking the derivative here with respect to u. So let's just bring down, we'll do a little chain rule, bring down the 2 to the 1, multiplied by the derivative of the inside, so that would be 2u plus 2. Okay, so that's our dy du is right here. That's this piece. Times du dx. Alright, so now we're just multiplying by the derivative of this piece. Derivative of square root x is 1 over 2 root x plus 0 for the derivative of 2. So that's it. But we like to write this in terms of x because we're taking the derivative of y with respect to x. So at this point, we're just going to replace u with square root of x plus 2. Okay, now over here, 2 square root x plus 2 plus 2 times, finally, times 1 over 2 square root x. So that's the whole thing. In part F, we're going to do a chain rule. Let's see, dy dx is equal to, first the outermost function is this set of square brackets, so we'll just bring down the 4, change this to a 3, copy over the inside, and now we'll multiply by the derivative of the inner function of this. So we have 3 plus, okay, now the derivative of this term is 10, 5x plus 7 to the 9th times 5. Okay, so that's the derivative of the inner, what I underlined. Okay, so there we have a derivative of outside times derivative of inside. And in G, we have y equals secant cubed 5x, and it'll be a little bit easier to take the derivative if we write this as secant of 5x cubed. All right, so dy dx is equal to, let's just bring down that 3, change the exponent to 2, and now we're doing the derivative of secant 5x. So remember, the derivative of secant is secant tan. So that would be secant 5x tan 5x times the derivative of 5x, so that would be times 5. In number 3, we're going to do some integration. In this first example, we have a sum of powers, and so we're just going to use the power rule. Let's rewrite this as a sum of powers. So that's 3x to the 7th plus 8. And here's where we rewrite, instead of cube root of x, let's write x to the 1/3 plus 5 dx. All right, so now we're ready to use the power rule. Remember, you just add 1 to the exponent and divide by the new exponent. So that would be here for the first term, 3x to the 8 divided by 8. Plus 8x to the 1/3 plus 3/3, that would be 4/3. Divide by 4/3 is the same as multiplying by 3/4 plus 5x plus c. In 3b, again, we can use the power rule if we divide through by x to the 1/3. So let's write that denominator as x to the 1/3. And let's start our division. So now we're rewriting our integral. We want to write this as a sum of powers. So here we have 7, and here we have x to the 6 divided by x to the 1/3. That's 6 is 18 over 3. So we have 18 over 3, subtract 1 over 3, so that would be 17 over 3. Minus 8, and here we have 3 subtract 1/3. So 3 is equal to 9 over 3. 9 over 3 subtract 1 over 3, that would be 8 over 3. Okay, so we rewrote our integral as a sum of powers. And now we're ready to integrate using the power rule. So here 17 over 3 plus 1, that's 17 over 3 plus 3 over 3 is 20 over 3. And divide by 20 over 3, or multiply by 3 over 20. And here we have 8 over 3 plus 3 over 3, that's 11 over 3, times 3 over 11. In number 3, we have what we call a definite integral. That is, we have these two limits of integration. Okay, these are the limits of integration. And the way we evaluate this is we simply integrate. Okay, here we're just going to use the power rule. And then we're going to substitute in the two limits of integration. All right, first the top one minus minus the expression with the second substituted in. So first substitute in the first one. So here we have 2 cubed, so that would be 8. Plus 2 times 2, that's 4. Okay, so that's what we get when we substitute in when we substitute in 2. Now let's substitute in 1 into this expression, so we get 1/3 plus 2. All right, and we can just subtract these. So we have 8/3 minus 1/3, that would be 7/3. And we have 4 subtract 2, that's 2. Okay, so we can combine these. 7/3 plus 2 is 6/3, and that's 13/3. In 3D, we see we cannot write this integrand as a sum of powers. So we can't use the power rule here, and the only other method that we have is the u substitution. So let's see if a u substitution is appropriate here. What we're looking for is we're looking for an inner function. That would be, this would be the inner function. All right, it's underneath a square root, so that's an inner function. And we're looking for the derivative of this inner function sitting on the outside. Well, the derivative is 2x, and we have x, so that's enough. We only need the derivative up to a constant. We don't really need the constant in front. Okay, so this is appropriate for a u substitution, and what you do is you put u equal to whatever that inner function is. So let's write u is equal to x squared plus 10, and du is equal to 2x, just take the derivative, dx. Now we want to do an exact substitution. Here we have an x dx, so let's solve for that, what we have. So x dx is equal to 1/2 du. All right, now we're ready to substitute. So instead of x dx, we're going to put 1/2 du. And we'll put the 1/2 outside the integral. All right. Instead of the square root of x squared plus 10, we'll put the square root of u. We can now almost do the power rule. We just have to rewrite this as a power, and then we can do the power rule. So 1 over square root of u is u to the minus 1/2. And now we can do the power rule. Minus 1/2 plus 1 plus 2 over 2 is 1/2. Divide by 1/2, which is the same as multiplication by 2. So this is equal to u to the 1/2. Let's replace u with x squared plus 10. So we have the square root of x squared plus 10 plus c. In 3e, we cannot use the power rule here. We can't write this as a sum of powers unless we multiply out x minus 1 to the exponent of 8. And that would take a long time. So we think about using a u substitution. And we have an inner function, and it's linear. X appears only to the exponent 1. So we're going to do what we call a linear u substitution. This is a little different from the u substitution we did in the previous part. We're no longer looking for derivative of inside sitting on the outside. All right, we're just substituting. We're just looking for an inner function that's a linear function. All right, in this case, du is equal to dx, taking the derivative of both sides. So let's start our substitution. Instead of dx, we're going to put du. Okay, so we replace dx with du. Instead of x minus 1 to the 8th, we're going to put u to the 8th. U is equal to x minus 1, so we replaced x minus 1 to the 8th. But now we just have to replace x. In order to do that, we have to solve for x. Let's add 1 to both sides, so we have u plus 1 is equal to x. So now we can replace x with u plus 1. We're still not in a position to do a power rule here. This is not a sum of powers, but now we can easily multiply through by u to the 8th and obtain a sum of powers. So let's do that. So we have u times u to the 8th, that's u to the 9th, plus 1 times u to the 8th, plus u to the 8th du. So now we do have a sum of powers, and we can use the power rule. Okay, and then finally to finish this, we'll just substitute back. U is equal to x minus 1. In 3f, there's really no hope of writing this as a sum of powers because we would have to multiply this out 10 times. All right, so again, we think about a u substitution. Here's our inner function. And remember that the derivative of 1 over t is minus 1 over t squared, and we have 1 over t squared here. So we pretty much have derivative of inside on the outside. So that's a u substitution situation. So we put u equal to that inner function. du is minus 1 over t squared dt. Now we don't have minus 1 over t squared, we have 1 over t squared. So let's multiply both sides by minus 1. And we have minus du is equal to 1 over t squared dt. Now we're ready to do an exact substitution. Instead of, we're going to replace 1 over t squared dt with minus du. Okay, so there we have minus du. And here we have u to the 10th. So we have a simple power now. Let's integrate, power rule. So add 1, we have u to the 11 over 11 plus c. And last step, just substitute back.